Beneath the streets of Paris, a new mechanical giant is rewriting the city's future.
Constructing 200 kilometers of tunnel is an engineering challenge of unprecedented scale.
But how do you carve through this complex geology without destabilizing the city above?
To understand the answer, we must return to the problem that defined the city's growth.
The city has long faced challenges with a transit system centered entirely on the historic core.
The design forced travelers to enter the heart of Paris just to reach a neighboring suburb.
Suburbs were isolated, creating traffic congestion that impacted the regional economy for decades. The goal was simple: build a peripheral ring that connects suburbs directly, bypassing the center. This vision, now known as the Grand Paris Express, is the largest infrastructure project in Europe.
Engineers faced a landscape packed with existing tunnels, foundations, and centuries of history. Beneath the surface lies a shifting, fragile geology that dictates every meter of progress. Designing a path that avoids historical monuments while serving dense communities was the primary constraint.
Engineers calculated forces to the millimeter to prevent subsidence in the vulnerable soft soil.
This wasn't just building a tunnel. It was surgically implanting an artery into a living city. Before the machines arrived, the sites had to be prepared for massive loads.
Logistics became the pulse of the operation, requiring a synchronized dance of supplies.
Each machine is custom-built for the specific soil density of its designated sector.
The assembly process is a testament to precision engineering, taking weeks to complete.
With the preparation complete, the machine is ready to bite into the earth.
The first meters are the most dangerous, as the machine adjusts to the local pressure.
Behind the cutter head, hydraulic arms install the tunnel lining with perfect seal.
Every movement is constantly monitored to keep the surface stable and the tunnel safe.
To understand the answer, we must return to the problem that defined the city's growth. Water control is the hidden battle. Keeping groundwater out is critical for structural integrity.
A pressurized slurry system carries soil away, balancing external pressure at the face.
Engineers on the ground walk the line daily, ensuring everything aligns with the design. Access shafts like this are the vital lifelines that bring materials in and spoil out. Above, the stations themselves are rising as massive hubs for the future network.
Reinforcement is the skeleton that allows these stations to handle urban pressure above.
Thousands of tons of concrete are poured, forming the permanent base of the project. Multiple work sites work in parallel, a coordinated effort across the entire suburban belt. Maintaining alignment over such distances requires laser-guided precision throughout the tunnel path. Passing within meters of existing infrastructure is a constant, high-stakes navigation challenge.
Small deviations can lead to ground settlement. Total awareness is the only prevention.
Samples are analyzed around the clock, feeding back into the machine's operation parameters.
Maintenance is not a choice. It is a rhythm that ensures the machine survives the journey.
Replacing these teeth is an grueling task, done in the high-pressure environment of the tunnel.
Human intervention is a last resort, requiring specialized training and immense physical courage.
The deeper the tunnel goes, the higher the pressure from the earth above. These sensors provide the real-time data needed to manage the structural load. The design must be flexible enough to handle the pressures without losing structural integrity.
Junctions are the hardest part of the project, requiring complex reinforcement and structural care.
Each connection point is verified multiple times before the tunnel is considered complete.
Some sections of the line move from tunnel to bridge, introducing new engineering obstacles. Building in water requires advanced underwater foundation techniques to remain stable over decades.
The structure is designed to handle extreme weather while maintaining alignment for high-speed transit.
Laying the tracks is the final phase of the process, requiring surgical precision. With tracks in place, the tunnel shifts from a construction site to a future transit artery. Air management is critical to passenger safety and long-term operation of the tunnel.
The brain of the system will control every train movement to maximize efficiency.
Automation ensures safety, reducing the human error margin to near zero.
High-speed communication links ensure that every train is tracked every single second.
Testing the system is a phased process, ensuring all subsystems work in total harmony.
The stations and trains are designed to provide a seamless, modern passenger experience.
Architecture blends engineering efficiency with human comfort, turning transit into a destination.
For the first time, commuters can travel between suburbs without entering the congested city center.
The time saved will transform regional economy, boosting connectivity across the Paris basin.
The Grand Paris Express is finally connecting the disparate parts of this historic region.
The final breakthrough marks the culmination of years of relentless engineering effort.
A moment of sheer accomplishment, shared by the teams who dared to make it possible.
It is the result of thousands of small, difficult problems solved one by one.
These machines, having completed their duty, leave behind a permanent mark on the city.
Where there was once raw earth, now stands a hub for millions of future journeys.
The network is woven into the city, making transit effortless and accessible to all.
The vision of a connected Paris is now becoming reality, one station at a time.
Covering 200 kilometers, the scale of this project remains truly breathtaking.
Dozens of new stations are redefining what it means to live and work in this region.
The volumes of material moved and poured are record-breaking, yet invisible to the public above.
For residents here, the commute that once defined their lives has changed forever.
Efficiency in transit creates freedom, allowing more time for the things that really matter. This project shows what is possible when engineering serves the needs of a changing society.
Work continues as new segments are integrated, ever refining the future of Paris mobility. Engineering is the quiet art of building a better future, one project at a time. And elsewhere, the next impossible challenge awaits.